Good morning, friends. This session we mainly describing about the statistical methods, how we can use and fundamentals of statistics. So, first part of this session mainly comprises of two main parts. That is, first is fundamental. Next session we will discuss about the various tools which are using in research, especially in engineering research. So, the first session contains the first session comprises of what is statistics, statistical methods, and statistical methods including descriptive statistics and inferential statistics and statistical data. Thus, what is statistics? Statistics is the body of techniques used to facilitate the collection, organization, presentation, analysis, and interpretation of data for the purpose of making better decision. Always our purpose is to make a good decision, which for making a good decision, statistics will help for you. Next, necessity of statistics, especially in engineering fields. Engineers deal with situations that are poorly defined and must make decisions using data that are not precise. Proper application of statistical analysis may help the engineers to deal with this situation. Optimization of a process or a product or the design of a device requires to be met both performance and production specifications. Engineers need to know how to describe, monitor, and characterize their work, and statistics provides the means. Actually, mainly statistical method is divided into two parts, that is descriptive statistics and another is inferential statistics. In this session, we will discuss about descriptive statistics. In the picture, we can see that one side this round is showing that the entire population and the other side the square is showing that the sample is always coming from the population, and on the basis of sample we are generating some indicators like minimum, medium, maximum, or average, or standard deviation, or some other relationship. And based on the sample information we are generating information, and with the help of inferential statistics we can generalize to the main population. This is the overall about statistical methods. Next, we are discussing about descriptive statistics. Descriptive statistics are the tabular, graphical, and numerical methods used to summarize data. Mainly, we will get data while doing experiments or research, whatever maybe. We will get data. So one wants to organize it, present it in a beautiful manner, and they have to convey their results to the third party or other presentations. So the better descriptive statistics is better for that. So in descriptive statistics, what we will do, we will arrange the data in a tabular format or graphical format or numerical methods used to summarize the data, which involves the descriptive statistics process involves collecting the data, organizing or summarizing the data, presenting data, and the main purpose of descriptive statistics is describe the situation. That is what is the thing actually we describe our results, or what is what is called our reports or our results of the experiments. That is the main purpose of descriptive statistics. Next, the one example we can see that here, the management of a car manufacturer would like to have a better understanding of cost of parts used for engineering service. So, for example, any kind of car manufacturer, they want to know the idea about what is the average cost, of their car's engine service. So they collected some sample from a particular shop or different shops, a particular service station or different service stations. They collected 30 samples, and the data collected were they presented in the below table. That is 90. All the figures are in hundreds. That is first service. First service cost was engine parts service cost was 19,100, and second 7,800, 9,300, and so on. Okay. So we have to actually this data will not give any idea to the management or the company. because this is just a data. So we have to arrange it, or we have to summarize it in a meaningful manner to present to the top management level or to the public. So first we can do, according to the descriptive statistics, we can classify it. So better understanding, for a better understanding, we can classify. We can group the data into different classes. So first we have to identify the minimum and maximum of the data. Accordingly, we can split the data. So my minimum is around 50 and maximum is around 110. So like that. So I classified this as 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99, and 100 to 109. After that, I will go to the data again. So after that, I will look into the data. How many service costs are within the range of this 50 to 59. That is only two service costs reported, that only two service costs are within the range of 50 to 59. Like that, 60 to 69, there is four service costs are there. Like that, 70 to 17 and 13, all the frequencies. That's actually this kind of data is called the frequencies. All the frequencies we noted here, and the total data, the sum of all the frequencies should be the total number of observation that we collected 30 service costs from a service station. That is the 30 here. And we can also calculate the percentage frequency. So 2 is the percentage. So we can calculate 2 divided by 30, that is 6.7 percentage. So we can explain that 6.7 percentage of the total car service cost is fall in the group between 50 to 59. Like that, 60 to 69, that is 13.3 percentage of the total. We can generalize that. So another method, this is the method of presenting in a tabular form, data in a tabular form. Next method actually given below is graphical method. Here is shown a histogram. So histogram is simply giving the data in a graphical or bar type graph. That's, you can see that 50 to 59 is in the x-axis, and corresponding to two frequencies are plotted with the help of bar, and 60 to 69, this 4 is here and 13, like that. The picture gives a sudden, will any layman get an idea about the service cost of a car from this picture easily. So presentation of data is important. So you can take it, there is no problem. Actually 50 to 59, what is your question about 60 and 60 plus, like that, 61, and that is an overlapping group. That means 60 is coming in two classes. The lower class is also containing 60 and the same 60. Suppose our in our data some service cost reported 60, exactly 60. Then which group it will go? That is the problem. So independent groups we have to create. So we will discuss about the descriptive statistics. Mainly statistics dealt with statistical data. What are the type of data? How we are measuring that data is it have a crucial role in statistics. So first of all, statistical data is mainly divided into two parts: qualitative data and quantitative data. Qualitative data, all of you know about that, color, gender, all these things are qualitative data. So the color, we can grade any color. We can grade any color with this qualitative data. So quantitative data is represent the quantity or amount of of something, such as length in centimeter, weight in kilometer, like that. These are the examples. So the qualitative data, I already said that the colors, yellow, blue, green, like that colors, that is the qualitative data, examples of qualitative data. Another major classification is discrete data and continuous data. Assumes values that can be counted. That is discrete data. Discrete data, what is meant? That is the values that can be counted. Such data are classified in discrete data. For example, number of defective items produced by a factory, and number of customers arrived in a bank. These are whole numbers, and we can classify this such category of data in this discrete data. And continuous data, we can assume all the values between two specific values. For example, we are measuring the length or measuring the weight. So we can all specify all the values. For example, length between 10 and 12. We can take any values 10.1, 10.2, 10.3, or 13.4, like any values. For in the case of length, weight, such type of data we classified under continuous category. Another major classification of data is based on their measurement, type of measurement. The type of measurement is one is cross-sectional data and time series data. Cross-sectional means, for example, we want to check the quality of a fuel of a particular day. So we can check. We can collect sample from different petrol pumps, the fuel sample from different petrol pumps, and accordingly we can experiment it in a laboratory and we can take the results. So such type of data we can have cross-sectional data. And time series data is something like that. So is move along with time. So we want to assess the fuel quality of in a continuous manner. Fuel quality in a continuous manner. That indicates that we have to take the sample in a particular interval. That's every first day of every month or last day of every month. We will take the sample and it's continuously processed in the laboratory and take the data. So such type of data constitute that time series data. For example, monthly sale data, daily temperature data. These are examples of time series data. Actually, in the cross-sectional data and time series data have much important in statistics, because in these two categories, the tool for analyzing are different. The statistical data again continues that already we discussed the qualitative data and quantitative data. Again, quantitative data we can divide into four parts. That is nominal data, ordinal data, interval, and ratio data. So nominal data represents the arbitrary code data that can only be classified to categorize, cannot be arranged in an order. Because I already said that we have a data of car colors, yellow, green, violet, something like that. So we can code that. We can assume one number for yellow, two number for green, four number for red, like that. But we can't order that, because we can't say that yellow is higher priority than green. We can't order that. Such data is the type of measurement is called the nominal measurement of data, and they have, in short, we can say that they have no numerical value. There is symbolical numerical value is there. So next is ordinal data, ordinal type of measurement. Ordinal data conveys ranking in terms of importance, strength, and severity, like that. For example, we are grading a mark system. So A grade, B grade, C grade. So we are assigning A grade is, that means above 80%, B grade is 60 to 80%, C grade is 50 to 60%, like that we can. So there is some sort of ranking is involved in such measurement. So such type of measurement is called ordinal scale of measurement. Such a type of data is called ordinal data. Next is interval data. Interval data is data allows us to addition and subtraction. Now, means simply saying that the whole numbers, something like that, we can say that interval type of data. Next is for example, temperature, Fahrenheit scale. These are interval data examples. And ratio data allows all the arithmetic operations, that is addition, subtraction, division, and multiplication. For example, mainly examples of these are size, weight, strength. These are the examples of ratio data. And data processing in natural 0 points and organized into measures for which differs are meaningful. For example, money, income, sale, profit. These are the examples of ratio data. So this chart gives you a better idea, understanding about the measurement scales and type of data. So left side the scales are there, nominal, ordinal, interval, and ratio scales are there. The third column, that's giving the categorical data. So ordinal categorical data can measure in two ways, that is in a nominal ways, nominal measurement type or ordinal measurement type. Same way, the last two column indicates the quantitative data. Quantitative data is mainly divided into two parts, discrete and continuous. So discrete data we can measure in such a way that ordinal measurement or interval measurement, and in the case of continuous data we can measure in the three ways: ordinal, interval, and ratio. Now we go for measures of central tendency. So that is the basic tools for statistics, that measures of central tendency and measures of dispersion. That is the basic things. So one how to this will gives a better idea to someone about the data, where it's concentrates regarding by analyzing measures of central tendency and how it's dispersed by using measures of dispersion. So the purpose of measures of central tendency is to describe a distribution's middle or center value. So suppose we take the example of, we already discussed the example of service cost. Actually we have 30 service costs there. So some presentation method we already discussed, the graphical method, table method, this. So one more method is the central tendency method. We can we can calculate a central tendency measure and present that this is the average cost of this, like that we can present that. So most popularly known measures of central tendencies are mode, median and mean, and some other measures of central tendencies are there, like that geometric mean and harmonic mean. They are specific purpose averages, so we are not included in this session. So first we will go for mode. Mode is the most frequent value of the distribution, only measure that can be used with nominal level of variables, because I already told that nominal measure have no numerical values. They have no ranking also. So this mode is the most frequency. Here we are checking only the frequency, how many times it's repeated. So for the example, the given example is series is given there: 10, 15, 12, 15, 12, 10, 12, 20, and 18. So what how we measure mode? Mode is the most frequent item. So which number repeats frequently? So 10 repeats only 2 times, 15 repeats 2 times, and 12 repeats 3 times, 20 repeats 1 time, and 18 repeats 1 time. So 12 is the most frequent item. That is the mode of this series is 12. Next item in the measures of central tendency is median. Median is the middlemost item of the distribution. So middlemost item means first we have to arrange the data series in ascending order or descending order. After that we can take the middlemost item. That is the total number of items in the series is n. Then we can, but how we can arrange the middlemost item? N plus 1 by 2. That is, here the below example, five items are there. So 5 plus 1 is 6. 6 divided by 2 is 3. So we can take third item as median. In the particular series 2, 2, 6, 9, 11. So third item is 6, and we can say that 6 is the median of this series. When n is the even number, actually the above example, that is an odd number, so we can add 1 and divide it by simply, we will get a whole number. So in the case of an even numbered series, so here given the n is 6 and the numbers are 2, 2, 5, 9, 11 and 12. So n plus 1, that is 7, and that is that will come to 3.5. We will not get any 3.5 item here. So what we will do? So simply divide by n divided by 2, that is 6. We will take third item from left and third item from the left right. So we will get 5 and 9. From the left, this 5, and from the right, it's 9. So add these two numbers, 5 plus 9, and divide it by 2, we will get 7. 7 is the median of the second series. Next measure of central tendency is mean. Actually, mean is a widely used the measure of central tendency. It is calculated by summing up all the observations of a distribution is divided by the total number of observations in that particular distribution. Symbolically says that x bar indicates the mean. Formula is x bar is equal to sigma xi by n. Sigma xi is that summing up of all the observation, and n is the total number of observations. 3, 5 below given a series is there. 3, 2, 5, 9, 11 and 12 are the observations. Sigma xi we can calculate 3 plus 2 plus 5 plus 9 plus 11 plus 12 is equal to 42, and n is 6, that because there is 6 observations are there. So mean we can calculate 42 by 6, that is equal to 7. 7 is the mean of this series. That indicates on an average the value, center value is 7 of this series. Where it can be useful, actually we already said the example of service cost. So we are giving the classification table and graphs. Better we calculate the average or mean. So that is a single digit number, that will give a single digit number. So we can say that this is the suppose 80 is the average service cost of that particular car. That will give a easy and understandable idea to a common man or a management professionals or some other persons. So the measures of central tendency help us to precise the data series into a single number and better understandable form. So next is measures of dispersion. Measures of dispersion, we calculated the central point of the series. Now further we want to know about how much dispersed the series is. So because we can calculate central tendency, otherwise average, for different series. Suppose different 2-3 series have the same mean, but their dispersion is different. So the idea of dispersion is also required for a better understanding of the data. So measures of dispersions mainly are variation, standard deviation, and range, etc. The most commonly used is standard deviation. So range is the simplest measure of dispersion. We can simply calculate that using the highest value minus the lowest score. So the example is here 3 to 5, 9, 11 and 12 is the series. So the lowest value is 3 and highest value is 12. 12 minus 2, lowest value is 2 is there. So 12 minus 2 is equal to 10. 10 is the dispersion. That means the entire data scattered 10 points. From 2 to 12 we will get 10 is there. So 10 point dispersion is there. Next is the most used measures of dispersion is standard deviation. Standard deviation measures the standard or typical distance from the mean. Actually, standard deviation is measured on the basis of mean only. So that measures the standard or typical distance from the mean. How it calculates? It calculates the sum based on the sum of squares, the sum of square deviations from the mean. So we already saw that we have some observation. We calculated the mean, that is x bar we calculated. What we will do? We have to subtract the average value from each of the observations. That is each of the observation that will give the deviations, and square the observation and add up this divided by the number total sample size, that is total number of observation, that will gives the variance, and square root of variance is the standard deviation. The number of credits a sample of 8 students are taking. The example is here. Xi is the number of credits of 8 students, that is 10, 9, 13 like that. the sum of the xi values are 112. 112 divided by 8, the total number of students, that is equal to 14 is our average or x bar value. So what we will do, we have to minus 14 from each individual observation, that is 10 minus 14 gives minus 4, 9 minus 14 gives minus 5, like that we will make the difference, and the sum of differences should be 0. And next step we will square it, that is minus 4 square is 16, 50 minus 5 square, that is 25, like that we will square the differences and sum it up, and the total we will get as 72. 72 divided by total number of students is 8, then that will give 9. 9 is the variance. And how we calculate standard deviation? Square root of variance is standard deviation, that is square root of 9 is equal to 3. 3 is our standard deviation. So 14 is our mean, and 3 is our standard deviation. Suppose how we use mean and standard deviation to understand a set of data. Suppose in the table we have some example that width of a road. Suppose some different highways we measured in a particular points, the particular distance. After every particular distance, they measured the width of the road, and 3 highways they measured such width, and they calculated mean and standard deviation for 3 of these three of these highways. That is, first highway the mean is 10 and standard deviation is 0.2. Second highway, that is mean is again 10 and standard deviation is 0.5, and third highway mean is 10 and standard deviation 0.7. So in all the cases, average width of the road is 10, but the standard deviation varies 0.2, 0.5 and 0.7. So it will give a better understanding of data which road have a uniform width or width. A high standard deviation shows that the data is widely spread or less reliable. That indicates high standard deviation indicates that data is less reliable, and low standard deviation indicates that the data is more reliable. So from this example, I highlighted this here. This highway 1 have uniform width. Okay, though all the highways have average width of 10 meters, but the highway 1 have the uniform width, almost uniform width, because that's standard deviation is lowest. So in such a way we can assess data with the help of mean and standard deviation.
For calculating mean, we require some data points.
Yeah.
So we divide the path में divide कर देते हैं.
No. Actually, we are measuring only. Suppose first initial point we measure the distance. After 10 kilometer or 5 meters, whatever may be the interval, we continuously measuring, and 30-40 place the distance we are measuring. Same process repeated in the case of another highway, and the same process we repeated in the case of third highway, and we got 30 observations, and take the mean of each observation. That gave the mean of each highway. Again we calculate the standard deviation in each highway cases. Accordingly we will get the data. On the basis of that data we are judging which highways have uniform width. Okay. Next is we already discussed about the descriptive statistics. Actually, now next main portion is the inferential statistics. Inferential statistics is the process of using data obtained from a small group of elements that is sampled to make estimates and test hypotheses about the characteristics of a large group of elements, that is population. So what inferential statistics do? It infers from the sample data. So I already discussed the previous example that we measured the width of a highway in different points, some sample points, and we are saying that that highway 1 is a almost uniform width. So we collected some sample data, and we are concluding that from the sample data that generalizing that the highway 1 have uniform width. So that is the case of inferential statistics. With the help of hypothesis testing and some other statistical tools, we can generalize the sample data to a population. Otherwise, who have generalized the statistical data, so that process is called a statistical significance. And the example that fuel efficiency of a make and model is determined by sample of a few cars. So we can't test all the cars manufactured by a company, but in that case, what we will do? We will collect. We will take some sample cars and test the fuel efficiency, and accordingly we calculated the average fuel efficiency, and we are saying that the entire car entire model of that car is the produced car is having this much fuel efficiency. We can normally terminate that Maruti Swift has this much the mileage that gives it this much mileage, and Hyundai is giving this much mileage. That all our company is generating in such using such a process, and they are taking samples from few cars and generalizing it into the whole car produced by the company. The next example is a time required by a robot to do a repetitive task must be determined by a few observers. So we some engineers prepared and manufactured a robot to undertake a particular task. So we want to know, actually sometimes engine machines efficiency may vary, depends on some conditions. So we want to observe that what is the average efficiency of that machine. So we will take some samples of that machine. We will take some samples from that machine. Otherwise, time taken for a particular task by the robot at a different time periods. So on the basis of that data, we can conclude that this much time that the robot can take for a particular doing the particular task. And the strength of a steel must be determined by the laboratory experiments. So we can't send all the steels manufactured to the laboratory for testing that. Instead of that, we are sending some sample steel, small sample steel parts to the laboratory for testing the strength of the steels and generalizing it that data to the the applied to the whole steel produced. And what is inferential statistics? That is we are looking through we are looking the population through a sample they are calculated, which the inferential statistics process involves that estimation, hypothesis testing, and the purpose is drawing conclusion or inference about the population characteristics. We discussed the different examples last time regarding the fuel efficiency test, the average time taken by a robot, and the quality of steel, like that. All the cases we are taking sample. On the basis of the sample, the data gathered from the sample, we are generalizing it for population, the entire population of that group. So here is a pictorial representation about the sample and population. The B square indicates that the population. So population, I am naming it as a population is a statistical terminology. So population is any kind of any group, whole group of things are called termed as population. So a group of cars produced by a particular manufacturer, that is a population of cars, and samples is the some selected cars from that group is called a sample. So whatever may be the parameters extracted from a sample is called statistic, and whatever the parameters extracted from population is called parameter. So sample mean, sample standard deviation, all we calculated before are generally termed as statistic, and population mean and population standard deviation always termed as parameters. Here we see this is a process of inferential statistics. First process, population consists of all engine services. Yeah, engine services. Average cost of parts is known. So Our aim is to understand what is the average cost of parts involved in an engine service of a particular model of car. The second process, a sample of 30 cars engine services were taken, and we collected the part costs involved in that service engine service. So we collected from 30 cars, and on the basis of 30 cars, we summarized, we calculated the average, we calculated the standard deviation, and the sample data provides the average cost is around 8,000 rupees. That is 8,000 rupees per service. Okay, so we have to generalize that sample based of statistic, that is 8,000 rupees. The average is the average cost of parts during the engine service. The value of the sample average is used to make estimates of population average. So we have to say that we have to generalize the 80,000 cost service cost to the population, entire population of the car. That is the entire process is doing by inferential statistics.